Hello everybody, welcome to the webinar which is called Introduction to ecoinvent version 3. This webinar is organized directly by us, the ecoinvent Center. My name is Teresa Levova. I work at the ecoinvent Center as a senior data analyst. My function during this webinar is only a technical support to my colleague Emilia Moreno Ruiz, which will be actually giving the webinar. Regarding the webinar itself, it's divided into several sections describing different issues and talking about different ways of modeling which is present in ecoinvent version 3. After each section, there will be what we call the wrap-up slide. So basically we will repeat the main points of what was being discussed. During this wrap-up slide, there we left also some time for you that you can ask the questions. The webinar is organized that only me and my colleague Emilia can speak. All the other attendees can only listen. But you have also the option to ask questions. And the way you can do it is you can see on your right-hand side in this panel, there is a section called questions. So there you can type in whatever questions you might have. We will receive the questions here and I will select the ones which I will think are valid for all the other attendees. And during the wrap-up slides, we will ask these questions out loud and then Emilia will answer them. In case there are some questions which would be too time-consuming or we think that they would not be interesting for the rest of the participants, we will not answer them directly in the webinar, but we will do our best to answer them afterwards to each person via email. So that was the most important information, and I would give the word now to my colleague Emilia, which will start the webinar.
Thank you, Teresa. Well, welcome everybody. Normally, I will repeat what Teresa have just said about the way you can ask questions and the way if the questions remain unanswered, we will email. But I think you are almost all here already, and she was very precise, and I think you all heard what she had to say. So, well, I'm Emilia Moreno Ruiz. I'm the deputy manager of the ecoinvent Center. I will be giving you this webinar, as Teresa said. And, this is the first webinar of a webinar series we're launching. This first one is an introduction to version 3, so it really wants to give you the basic principles on the new version 3. The idea is to facilitate you to start working on the version 3 with this webinar. So in the webinar series, all the webinars will follow that will be more focused on one specific feature, one specific part of the database. So yeah, just a very short introduction on the ecoinvent Center. The ecoinvent Center was founded by several Swiss institutes and institutions in 1997, and the database, the ecoinvent database, is up and running since 2002. We have been the world-leading LCA database for over a decade now, and it's important for us that you remember that we have always been, and we still are, a non-for-profit association. The version 3, a very short also introduction for you on the version 3. The ecoinvent Center published the version 3.0 of ecoinvent in May 2013. The version 3.1 of the database was published in July 2014, and the version 3.2 is coming now in 2015. Releases, as you see, are happening every year, and that's our aim. Releases will be happening every year. What I mean by a release, every release concerns the addition of new data to the database, and also it concerns corrections or improvements that are happening throughout the whole database, so transversal corrections or additions. As I already said, this presentation aims to be a very operational introduction to version 3. And you can learn more because we have publishing here and there in our webpage several documents concerning how to better understand version 3, how to approach version 3. So here you have a few links that you can look into, and you will find useful information on the database, or also you will find in our forum questions from other users, and of course in the support you will find frequently asked questions and also the possibility to contact us directly. And of course you will be able to learn more, as I said, in the future webinars coming, and also in the ecoinvent Matters series that we want to launch, that will devote, there will be short videos devoting themselves to very specific and short features on the version 3. Just to locate or situate everyone on the same page, this webinar is about the database, the ecoinvent database, and in all examples, everything I will be showing, it will be focusing on the access to the database through our ecoQuery, so through our web page. You can access, if you have an ecoinvent license, no matter with whom you have bought it, you can access the ecoinvent database through our web page. And this access, it's called the ecoQuery. There are two ways you can access to the ecoQuery. One is just logging into our web page and then going to those two upper buttons that will allow you to connect yourself to the version 3 or to wherever other version of the ecoinvent database. Just a reminder, every release of the ecoinvent database from version 1 to version 3.1 is available if you have a license, and you can connect yourself to any of those versions using those buttons. You can also access directly to the ecoQuery just by clicking on this link. And this is the link I will be using every time you will see a screenshot from the ecoQuery. Well, in the bottom of the slide you will see this link. The content of this webinar, as Teresa was advancing, the webinar is organized in 5 sections. We will start describing how was the change from process in the version 2 to activities and products in the version 3. We will then go deeper into the definition of activities and products and what types can you find in the database. We will then talk about creation and use of consumption mixes in the version 3. This is about the markets. This normally we receive several questions from the users beforehand and before every webinar, so we will address some of them here. We will then talk about system models, the system models we have published so far, a definition and a very short overview of each of them. Remember, this is really an introduction. We will stay very basic. And we will then end up by describing the new data and new features we have in the version 3. I will be using normally as examples one of our system models, the system model which is cutoff or recycling content. So this is the system model I will be using as an example normally. So let's start with the migration from processes in the version 2 to activities and products into now the version 3. So while the version 2 had processes, and you can see here the process it's all in green, and every time I will be referring to the version 2, everything will be green, so that's how you can follow also the visual part of the presentation. So while the version 2 had what we call processes, the version 3 is now organized in activities. And an activity can be really assimilated to a process in its definition, meaning that it's just a series of events that will produce a result. The difference now is that the outcome bears a different name in the version 3, while that was not the case in the version 2. So the activities will result in products. Those are the outcomes of the activity. And as I was saying, they bear different names than the activities that produces them. So if you remember version 2.2, that was already the case in the multi-output unallocated processes in the version 2.2. For example, in the version 2.2, when we had mining processes, the process, and then the outcomes of the process would have different names. But you, as users, were normally having access to the allocated processes, and in that case, the process and resulting output used to bear the same name. So in our example here in the slide, we are talking about lime hydraulic production. So while in the version 2, the process and its outcome were called lime hydraulic at plant and with the geographical information, in the version 3, the activity is called lime production hydraulic, and the outcome, so the product, is called lime hydraulic. This dissociation between activity name and product name has several consequences. First is that different activities can now produce the same product. If we stick to our example, we have lime hydraulic, we can imagine different producers of lime hydraulic with different technologies. The activities will be called differently, but they would all produce the same product, lime hydraulic. That means that you can now spot and select and filter and group different producers of the same product, something that was not possible to do in the version 2. Of course, I insist the naming has changed between version 2 and version 3 because of this dissociation between product and activity name, and also because we have added a naming rules for consistency reasons. So now the activities will bear more, let's say, process-oriented names. They would bear terms, they would have terms like construction, operation, and product names will have been they have been harmonized. Let's see some examples on how the naming has changed. And first of all, let's look at the bottom of the slide. Here you have a link. This is linking to an Excel file, which is your map between version 2 and version 3. If you use this Excel file, you will always be able to find your process in version 2 and what is now the corresponding activity name in version 3 and what is now the corresponding product name in the version 3. So this is a very important file to have and to use if you are migrating from version 2 to version 3. And if we go to if we look at the table in the slide, if you look at the two first lines on the table, this is just representing this example of different producers producing the same product. So those are different means of producing electricity, high voltage. So you can see the product in version 3 is always called the same, electricity, high voltage. The activity name is different, representing the different technologies that are being used to produce the product. And in the version 2, of course, the processes also were having different names. The two last lines, they are there to represent this change that was aiming to give to the activity names a more process-oriented name. So if you can see in the bauxite at mine example, the activity is now called bauxite mine operation, and the product, so the outcome of the activity, is called bauxite without water. In the process that was called in version 2 chemical plant organics, the activity name, now it's called chemical factory construction organics. So it's really reflecting the fact that this is producing, constructing, doing something. And the product is chemical factory organics. So the outcome, the result of such activity of constructing. Just to close this this first introductory part, those are the messages I would like you to remember. Processes are now dissociated into activities and products, products being the outcome of the activity. This will allow different activities to have the same resulting product. So the producers of the same product can now be easily identified, found, filtered, selected, etc. This means that naming has changed between version 2 and version 3. And here again, this is the link that leads you to the correspondence file. That it's this map between version 2 and version 3. That's how you find your way if you're moving from version 2 to version 3. And then there's a link to the change report. Change report is a PDF report where you have the documentation of all changes that were happening between version 2 and version 3, so you can also follow. I'm not sure we have questions on this part. Maybe we can keep on moving. Teresa?
We don't have any questions so far, so I think we can just proceed.
Okay, thank you. So then let's go deeper into the definition and description of activities and products. What is an activity in the language, so to say, of the version 3? An activity is a uniprocess that is representing a human activity. So it's this in the visual part of this webinar, and in general in the visual part of many documents of ecoinvent, the activity will be this red square. And this red square is representing a human activity. And so the activity has exchanges with the environment, of course this in the form of resource getting in and emissions going out. And it also has exchanges with the technosphere, so meaning with the products of other human activities. So you have inputs of products like infrastructures or like raw materials, etc. And it will have an outcome of products, which in the case of the version 3, when we're looking at the unallocated activities, those are producing two types of products. The reference product, which is the main product of the activity, and then co-products, which in the version 3 they are called byproduct/waste. There are different types of activities that we distinguish in the version 3. There are two types of activities. The first one, which we are addressing here, are transforming activities. Transforming activities are really activities that are human activities that will transform inputs. So that the output of the activity will be different from the inputs. Let's take an example. Let's focus on electricity production. This activity is electricity production hard coal in Australia, and it will have exchanges with the environment and with the technosphere, as we described before. And as you can see, of course, the input of the activities are different from the output of the activity, which is electricity high voltage, because there's a transformation, there's a process, there's an activity that is transforming the different inputs into different outputs and emissions. We have already discussed it, but let's go into the details of different transforming activities can produce the same product. So we have already talked a little bit about this when we were discussing the change in the naming, but let's get into an example. Here we are still talking about electricity production. This is hard coal technology again, and it's producing electricity high voltage, and it's located in Australia. Of course, we can change now the geography, and we will have the same activity, which is the same technology, which is electricity production hard coal, but it's located in a different geography, in Russia, in this example. And still it's producing the same product, which is electricity high voltage. Of course, we can have similarly different transforming activities producing the same product, but now we will be talking about different technologies. So we have our example that we were using. This is electricity production with hard coal in Australia. And we can have another producer in Australia of electricity high voltage that will be using a different technology, like, for example, electricity with hydro pumped storage. So just remember, different activities, different transforming activities can produce the same product because of different technologies or different geographies. There's a special type of transforming activity which is called treatment activity. This is something that seems very new when you start working with the version 3, and can be in the beginning confusing, so we sometimes have questions on that, and so let's try to go through it. It's really easy to understand, and it's a very key point on this webinar that you really understand this, so don't be shy to ask questions if you're not really following. What is a treatment activity? A treatment activity is a transforming activity with a reference product with a negative sign. Okay, let's see. So here we are. This is an activity, well, the red square is the treatment of waste paperboard by municipal incineration, and the reference product is a negative flow. It's a negative flow of waste paperboard. Okay, but for the rest, this is a normal transforming activity with inputs and outputs from and to technosphere. So you have inputs of oxygen in this case, resources, and then you have emissions like carbon dioxide, fossil, and also, of course, exchanges with technosphere. So you have the incineration facility that will be coming in and co-products like heat that are produced because this is incineration. So the only strange thing that can disturb the new users is this reference product with a negative sign. So let's just focus on this. This activity, the fact of having this reference product with a negative sign, is meaning that the activity is supplying the service of treating or disposing of the reference product. And in order to understand this better, let's connect together this waste treating activity. Let's connect it together with the waste producing activity, which in our example would be glass wool mat production. Glass wool mat production is a normal, so to say, ordinary transforming activity that produces glass wool mat, as you can see. As a co-product, so as a waste, glass wool mat production is producing waste paperboard. As you can see here, the waste producing activity, so glass wool mat production, has, that's how you can see it as final users, is having a negative input of the waste produced. So it's having a negative input of waste paperboard. This flow has been moved from the output side, where it was physically produced, where it happened, to the input side, where you can see it now, using this sign change. And this allows to maintain mass balance within the inventory. That means that we have moved waste paperboard from the output side to the input side, changing the sign, and so maintaining the mass balance in the inventory glass wool mat production. Okay. And the same has been done in the treatment activity. In the waste treatment activity, which is the municipal incineration, the negative output is actually an input of the waste coming in the municipal incineration activity. So it has been moved from the input side to the output side using the negative sign in order to maintain mass balance. And so this movement allows now to allows this waste treatment activity to represent the fact of treating or disposing of the waste. In the treatment chain, when now the waste treatment activity and the waste producing activity will be connected together, the negative signs are matching. So, first of all, this is correctly situating the supply chain of disposal in the upstream of the activity that is producing the waste. And second, the two negative signs are cancelling each other. Important to remember is that the negative sign is allowing to maintain mass balance, as I have said, in the two activities, in the waste producing activity and in the treatment activity. And by no means the introduction of those negative signs is changing the results of your impact assessment. This is nothing to do with that. Those negative signs are simply used as a mathematical trick, so we are able to construct a reasonable supply chain for the waste treatment, maintaining mass balance in all activities. And if you are an advanced user of the version 2, this way of organizing the treatment chains is not so new. It's new because of the sign, because of the negative sign introduced, but not because of the organization. Let's look at this slide. This is the waste treatment in the version 2. You see everything is green. This is version 2. So it's exactly the same example we were looking at before. We have on the right side of the slide the waste producing activity, which is glass wool mat plant, that's how it was called, the process at the time. And At the left-hand side of the slide, you have the disposal process, which was disposal of the packaging cardboard to municipal incineration. The waste was modeled as an input of the disposal service. So it was not modeled as an output of waste, it was modeled as an input. This allowed to locate the treatment chain upstream as well as in the version 2. But the fact of modeling the disposal as a positive input was generating an imbalance in both inventories. Thing that we are now avoiding by the introduction of negative sign, as we have seen. Okay, let's scroll down into the second type of activity you can find in the version 3, which are market activities. Market activities, they all also have, we also have lots of questions around market activities, and the first thing you have to remember about market activities is that the market activity is representing, the core of the market activity is a consumption mix. No more, no less. The core of it is a consumption mix. You have to, it's not any economical considerations concerning, no, it's a consumption mix, and a little bit more that I will explain now. Consumption mix, just to have everyone on the same page, is the production mix of a geographical location defined, normally a country, plus an imports minus exports. Here it is. Something else I want to remind you, especially if you are users from the version 2, is that the version 2 also had consumption mixes. The difference now is that they are available for each and every product in the database, and they add some information that I'm going to explain now. For the rest, as I was saying, it's a consumption mix. So here we have the market for electricity high voltage in Australia. So you would have the different inputs from the different producers of electricity high voltage in Australia. And this will be delivering the electricity high voltage. That will be the consumption mix delivered in the same geographical location. I was saying that markets are a little bit more than consumption mixes, and they are, because they also contain default information relative to the transport of the product from the producers to the consumers. So in the case of electricity high voltage, this transport is represented by the transmission network. I want to address here a question that we had from a user, and he was questioning, well, I may read it because it will be easier. I know that some transport is included in the market processes, but where does that boundary end? Should I be adding the transport that occurs in my own product supply chain to market processes? This is a very good question. As I was saying, the transport, the default transport that we are adding now systematically in the markets, it's different than what was done in the version 2. In the version 2, the transport of the different inputs had to be added in each of the activities using them. Now, transport from producers to consumer, the default one, is added systematically in the market. But if you have in the boundaries of your activities an internal transport occurring, of course, this you have to model as transport within your activity. The market is only taking care of transport from producer to consumer. The market also includes information about losses. That means that a market can also include, for example, emissions, because in this example of market for electricity high voltage, we have this emission of ozone, that it's related to the losses happening during the transmission of the electricity. Similarly, that we have been discussing before, markets for the same product can have different geographical localizations or locations. We have the market for electricity high voltage in Australia, similarly as we have in Russia, and because this example is electricity, we have market for electricity high voltage in many countries in the world, covering up to 90% of primary production. So, the markets, of course, they will also exist for wastes, and they will represent the consumption mix of the waste treatment. So if we have this market for municipal solid waste, these will be will get inputs from the different waste treatments that are available. So for example, inputs would come from incineration, from landfilling with specific shares, and this will be delivering this consumption mix that took into account those shares to the activities demanding it. Of course, markets for waste, they also include default transport information, similarly as any other market. So as I said in the beginning, there are just two types of activities. Remember that. There are activities that transform inputs into different outputs, which are the ordinary transforming activities like electricity production, or the waste treatment activities, which would have a negative reference product. And you will have the markets, which are activities that are there transferring different inputs and constructing a consumption mix that can be transferred to activities consuming this consumption mix. And you can find the markets for, let's go, ordinary products like electricity high voltage, or of course for waste like municipal solid waste. So they would have a negative reference product. Just to wrap up here, there are two basic types of activities present in the database: transforming and market activities. Market activities are consumption mixes where transport information and losses of the product during the transport have been added. And the treatment of waste is modeled like in version 2, an entry of disposal in waste producing activity, except that in version 3 negative signs allow the maintenance of mass balance in the activities. So, Teresa, I think we can keep on going.
We actually have
section of the webinar.
We actually have two questions. I think you already talked about it, but based on what the user writes, it seems it's not 100% clear. So
okay.
I will read the question. Glasswool mat production technically is producing waste paperboard as an output. But thinking further about this, ecoinvent version 3 wants to link this to the treatment of waste paperboard, and it does this by making waste paperboard an input.
Yeah, I mean, it's actually a quite good summary of what I have just said. Yes, the idea is to be able to connect the supply chain of the treatment of the waste upstream of the activity in order to then to be able to allocate the burdens correctly. So how we do that is that we have moved this waste paperboard that physically is happening on the output side, as exactly the user is saying. We have moved it to the input side, and by using this mathematical sign, mass balance is kept. And then this can be linked exactly to the treatment of the waste paperboard, but then it's located upstream. Yes.
And then the second question, which two users ask almost the identical question, is how is it possible, or how come that there was no mass balance in ecoinvent version 2 in the past because of how the waste was treated?
Yeah, well, because I would say because that's the way it was done. It is important for the version 3, the mass balance, and this is something that was not so addressed or was not so important. I wouldn't know how to phrase it in the version 2, but it's now very important in the version 3 in order to be able to use another kind of features that we would see at the end of the webinar, like carbon contents, and to use them for balancing as well. So mass balance is so to say, a worry that it's probably new in the version 3 and didn't exist so much before.
Okay, that's all for the questions now.
Okay. So then let's move to the third section of the webinar, which is about the creation and the use of those consumption mixes, of those markets in the version 3. So the version 3 will construct the consumption mixes in a systematic way. I already said consumption mixes will be available for each product, That's the way we construct them systematically for each product. So first, the transforming activities that will supply the market will be identified, and this will be done depending on their geographical location. So geographical location of the transforming activities and of the market would need to match in some way. Then, as I say, this market is then the one that will be articulating around it based on its geographical location, will be articulating which transforming activities will be supplying it, and we will see later which consuming activities will be taking inputs from it. There will exist at least, always at least one global market per product. But of course, regional markets will also exist when it's needed, when it's necessary. The consuming activities of those consumption mixes will then be also identified based on the geographical location of the market and on the geographical location of the consuming activities themselves, of course. And if those consuming activities are asking an input of consumption mix, then they will get the input from the market automatically. Of course, there's also, and it exists in the database, the possibility of having direct links between consumers and producers. And this direct link, of course, is overcoming the consumption mix. In order to construct this, because the consumption mix generation and used is articulated and based on the geographical location of the market and of the producing and consuming activities, the geographical coverage has been completed in the database in the version 3, and this has been done through the systematic introduction of global data sets. That means that now each transforming activity you will be looking at will have a global counterpart. And as I said before, each product will have at least one global market. Let's take an example. Let's go together and let's see how the consumption mix is supplied and then used by producing and transforming activities. I have chosen this example of the market of soybean. So far, the market for soybean is only global in the database. This is soon to change, but so far we can use it like this. And the market of soybean is delivering, of course, the reference product soybean. The consuming activities, because the market is global, then boundaries are global, so the geographical boundaries, I mean. So then I have picked up two consuming activities that are consuming soybean. Those are soybean meal and crude oil production, and they are located in Europe or in global as well. They will produce soybean meal. And those two activities, they have inputs of consumption mix of soybean. Who would be the supplying activities? So suppliers are located in different geographies in the world because the market has a global coverage. So there will be soybean producers located in the US, in Brazil, and in the world. The producers will be defined with production volumes. That, as you have seen now, it has been highlighted with those small circles. What is this production volume? The production volume is representing the amount at which the product is produced in every of those activities. So it's an amount that is given per year. Let's see how it looks like in the ecoQuery. As I said, I will be showing screenshots of the ecoQuery to illustrate some of the concepts I was developing. So if we stick to our example, let's just see how the soybean producer in Brazil looks like in the ecoQuery. That's the information you can see. Of course, much more. This is just a small screenshot. And here you can see the annual production volume. The annual production volume is then representing the amount of soybean that is produced in Brazil in a year. And this comes also with comments which explain how this production volume was estimated or where the information was taken etc. So here in this case, it's 2.68 10 to the 10th. So, as I was saying then, the activities sorry, will be characterized by the production volumes of the product in each of those activities. And is by using those values of production volumes that the market shares will be defined. So those absolute production volumes will be used to calculate relative production volumes that can be translated into market shares. So this will be defining the shares or the relative contribution of each of those activities to the consumption mix. That's how the consumption mix will be shaped. Then the addition of the absolute amount of production volumes will be reflected in the market, meaning how much of soybean in this case is available for consumption. And then this supply chain that has been shaped and drawn like this will be feeding the consuming activities that are asking inputs of soybean from the consumption mix. It is important to remember that one of the advantages of shaping the market activity or the consumption mix like this is that any addition of a new producer in successive releases, we might have new producers of soybean, we might have Argentinian soybean production, that would be nice. That will then modify the relative production volumes, so that will modify the market shares, and then that will result in a different consumption mix that will be immediately updated for the consuming activities that are taking inputs from the consumption mix. And that, of course, as users, you can also take advantage by always using the latest consumption mix, so the latest, the more recent market available in the successive releases. Let's take another example on the construction of a consumption mix at a more regional level. So, for example, we are taking the market for electricity high voltage in France, and of course this market has some location is only France. So what it will be averaging are different technologies, not so much different producers in different geographies as was the example before. Here we are maintaining the geography, it's always France, but we are averaging different technologies. So here I have just picked up the three more important production means of electricity high voltage in France, which is the nuclear, hydro, run-of-river, and natural gas. And as a consumer, I'm using transport passenger train, which is taking input of the consumption mix of electricity high voltage. As I was saying before, here you can see the absolute production volumes associated to each of the reference products in each of the activities. And here you can see the market shares, so the relative contribution of each of those activities to the consumption mix that it's delivered by the market. And you can also see the total production volume that is accessible through the market, which is 5 to 10 to the 11th. I already mentioned it. There's, of course, we use in the database direct links to overcome markets when the consuming activities, they are asking from an input from a specific producer. This, of course, happens in the database. And let's take an example in this same context. We have this electricity high voltage consumer, which is called electricity production nuclear aluminum industry, which is located in UN Europe. So this is taking inputs from electricity production nuclear only from it's taking inputs from electricity high voltage that is produced in the different countries that are considered in UN Europe, and this is done by direct links from the different producers of electricity high voltage nuclear in the different countries. They are directly linked to this electricity production of the aluminium industry. And then that's really how it should be. Just remember also, as a final user, you have the choice. You can always choose between using the outcome of the supplying activity, of a precise supplying activity, or using the consumption mix. Here in this example, again, it's a screenshot from the ecoQuery. You can see that you can, if you want to have an input of barley grain, you can take it from producers in different geographies like Germany, Spain, France, and you can take also the outcome of the market, so the consumption mix. This is of course up to you as final user. Just small, two very short slides to show you that the consumption mix of wastes is generated exactly the same way and following the same rules as the consumption mixes of more ordinary products. So here I'm focusing on the market for municipal solid waste, which has a global location, and I'm just naming two treatment activities of municipal solid waste, which are municipal incineration and sanitary landfilling, and just mentioning one consumer of the treatment of municipal solid waste, which will be kraft paper production bleached. So, as I was saying, the consumption mix, so the market generation and its use will follow the same rules as we described. It will be based, so articulate based on the geography of the market, so around that you will articulate who are producers and who are consumers. It's based on the product name, so different technologies can fit the same market, so this is the same as the examples we have seen. And again, it's using production volumes to define market shares. So it's constructed following exactly the same rules. So just to retain from this part, or to wrap up a bit, markets link together producing and consuming activities in the geographical boundaries described by the market. But when needed, in the database, we have also linked together directly producers and consumers of a specific product. As final user, you can always choose between the outcome of the supplying activities or the outcome of the consumption or the market. The market of wastes are generated and used following the same rules as for ordinary products. Teresa, can we?
Yes, there are questions. Let me select one or two. So one question is, what is the difference between market and country electricity mix?
Okay, so well, country electricity mix, for me it's a bit ambiguous, but let's say you can be talking about country production mix, maybe?
I think that the user might be not sure whether what is the difference between production and consumption mix and.
Okay. Okay, the market is representing, as I said, a consumption mix plus transport. So the consumption mix is the addition of a production mix of a country. So if we take the example of electricity, because that's also a good example to see that, you would have France. So you could define a production mix, and that will be covering all producers of electricity within the region France. Okay. Then, if you want to define what is really the consumption mix available for final consumers, you need to take into account imports and exports of electricity to France and from France to other countries, right? So, if to the production mix we add the imports and we subtract the exports, we get the consumption mix. And if to that we add transport, then we get our market. That's what you find in the implementation.
Great. Then we have one more question here. Where is it defined? What kind of electricity is the aluminium industry using? Is it considered in the market or somewhere else?
So the aluminum industry uses specific mixes of electricity, and how the specific mix is composed, this is defined normally in the report the Aluminum Association will publish. I think that every year, and this is the Aluminum Association who has delivered the data into ecoinvent. So that's how the pools of different producers are defined. And then they are, of course, to be constructed, they are constructed following the same rules as any other market. So they are taking they are constructed based on imports and exports from different producers. So it's the same type of construction.
Okay, no more questions.
So then let's move to the fourth section of our webinar, which is about the system models. And let's give a short overview on the different system models we have published already in the 3.1. So what is a system model? So a system model will be a collection of rules that allows the calculation of different versions of the database. That's what it is. So let's try to understand this together. If you look at the bottom of this slide, you have this white square. Okay. This white square is representing the database as it's actually created and maintained, right? So it's the database, the ecoinvent database is created and maintained and improved and stored as a collection of multi-output uniprocesses that are unlinked among themselves. What do I mean by multi-output uniprocess and unlinked among themselves? I mean that these uniprocesses will represent a physical description of each of the activities. So you would have the inputs and the outputs, and everything will be where physicality and mass flows is meaning them to be. So that's what you would find in the white square. On top of those white squares, we will apply those linking rules that will allow us to construct the different system models. So being the linking rules a collection of rules, we can apply in principle an infinite collection of rules. So far we have applied 3 collection of rules, but in this example where we are, you can see 2 collection of rules, linking rules Y and linking rules X, green and pink. So depending on the linking rules that you would apply on the white squares, you would get different single output uniprocesses and different cumulative LCA data and different LCIA results, of course. What are those linking rules concerning? Well, the linking rules, they concern different modeling choices, like how do we solve allocation problem, how do we treat waste streams, how do we handle constraint in suppliers. So depending on the decision that you are taking in every of these choices, you can shape differently the linking rules. As I said, ideally you can shape an infinite number of linking rules. So far, as I was saying, we have published 3 system models. So we have applied 3 different sets of linking rules, of modeling choices, so to say. This is again a screenshot of the ecoQuery. That's what you see once you have logged into the version 3. That's the first thing you will see. So this first option that you have, that's the first thing you can explore. It's called the undefined system model. Well, actually, this is about the white squares we were seeing before. This is the undefined version of the database, and this is the collection of unallocated and unlinked multi-output uniprocesses. You only have uniprocesses here, of course. You don't have LCI or LCIA because this is before you can apply any linking rule. Okay, they are very useful if you want to look at the original inventory. That's where you should look if you really want to see how the inventory was constructed, how you would see the waste flows in the output side, and you would see the activity describe the physical description of the activity, as I said. Then you have the 3 system models we have published so far. There are 2 that are called that will apply allocation. So we have allocation cutoff by classification, also called recycled content in CIMAPRO, I think. We have allocation ecoinvent default and substitution consequential long term. In those 3, you have access to linked uniprocesses, LCIA and LCIA, of course. So what will be the difference between system models? What are the modeling choices we are considering and how do we do that? So there are 2 main decisions that were taken. One is how do we deal with byproducts, and the second one is which producers are supplying the consumption mix. To the first question, how do we deal with byproducts? Well, we have 2 answers, allocation or substitution, so system expansion. Who is applying allocation? Well, as you can see by the name, the 2 system models that are called allocation, cutoff by classification, or allocation ecoinvent default. And who is applying substitution? Well, this is substitution consequential long term. As an answer to the question, which producers are supplying the consumption mix? Well, we gave 2 possibilities. One, average suppliers, meaning all suppliers are providing the consumption mix, are supplying the consumption mix, or only marginal suppliers and constrained suppliers are able to supply the market mix. The first choice, or the choice of using average suppliers, this is used by the allocation, cutoff by classification, and allocation ecoinvent default, and marginal suppliers supplying the market is used by the substitution consequential long-term system model only. I will zoom on a little bit on this system model, which is called allocation cutoff by classification, or also recycled content in CIMAPRO, because this is very important. This is the system model that is giving you continuity from version 2.2. This system model reproduces in a different way if you want, but reproduces the same modeling choices as we're taking in the version 2, now in the version 3. So if you want to move from version 2 to version 3 and keep a continuity because you need comparability or because you want to keep on doing what you were doing and start understanding slowly the other system models, this is the good choice to make. You can start by this. Your results you can compare with version 3, and you can little by little start understanding how useful the other 2 system models are, because you can use ecoinvent default for your sensitivity analysis, and if you're doing consequential you might think of, oh, maybe I want to understand what the substitution consequential long term about. But if you just want to move in continuity from version 2 to version 3, you can use allocation cutoff by classification. Just as a reminder, how were byproducts dealt with in the version 2? So if you remember, if you were users of the version 2, byproducts were classified informally in 3 different classes. A byproduct that was allocated as a co-product, recyclable material that was cut off, so just it was not listed in the inventories, waste that did not exist as a byproduct, but as a product of a treatment service, as an input, as we have seen in the examples of the construction of the waste treatment chains. And any byproducts obtained of the treatments were usually also cut off, so not inventory, not listed in the inventory. What problems were associated to that? Well, that the boundaries between the different classes that I just mentioned were not clearly defined. The classification was quite informal, as I said, and that the fact of cutting off flows from inventory meant a loss of transparency. You could only see which wastes or which recyclable materials or which useful co-products were produced in some points by looking at the reports, but you could not see them in the inventories anymore. And then, well, we have insisted a bit on that, mass balance were not possible because service inputs were having the wrong sign. So how do we deal now with the cutoff in the allocation cutoff by classification system model? So there is no cutoff within the activity in the version 3. There is no cutoff in the inventory. All co-products are considered in the activities because we aim for completeness. So there's no cutoff at this level here. The allocation that will be performed just to set the scenario will be physical or economical. So how do we do the allocation here? We have classified, here you can see this is a graph representing the 2,500 different products we have in the database. They are classified on 3 categories. And this is a classification that you can see associated always to the product. So you will have the product and then you will see in which category it's classified. So there are 3 categories: ordinary byproducts, recyclable, and waste. And it's the fact of being classified in one or in another of the categories that will determine how, as a byproduct, the product is allocated in the cutoff system model. Let's take a bit of an example to see that. If we have this transforming activity that it's producing product A and B, those being allocatable byproducts, and then producing a waste and a recyclable material, we would find the waste and the recyclable material on the input side with a negative sign. We have already discussed this a few times. And allocation will be performed here at this specific moment. How it would be? Allocation will happen between product A and B because they are classified as ordinary byproducts, so allocatable byproducts. And waste and recyclable material will behave differently. So in the when connecting to the treatment activities, the waste will come with full burdens, while the recyclable material will come burden-free. Let's focus on only this part, and let's see in a bit of more detail what's happening when I say it comes burden-free or it comes full burdens. That's how it is after allocation. We have the negative input of a waste and the negative input of a recyclable material. So the recyclable material will receive or will be linked to a chain which consists of a burden-free activity that has been specifically generated for this recyclable material because this product has been classified as recyclable material. So that's where we set the point of cutoff. Because this recyclable material is classified like this, an activity which is burden-free is specifically generated and linked here, giving a burden-free chain upstream. So, in the case of the waste, because this product is classified as a waste, it is linked to the treatment chain. So it comes with full burdens of the treatment of the waste. If another useful byproduct, let's call it product C, is produced in the waste treatment, it will be delivered, it will be accessible burden-free. So that's where the point of cutoff is. So the point of cutoff is separating primary and secondary use phases. Okay, and just to give a short overview on the 2 other system models, for the allocation ecoinvent default, allocation is applied in what is called the point of substitution. So in a way, it's a system model that applies allocation but takes system expansion into account. So this point of substitution is the point in the treatment chain where the economic allocation is possible, where substitution can be applied. Allocation is physical or economic. And substitution consequential long-term is applying substitution, so system expansion. Just briefly also, this is a quite common question, why do my results differ from version 2.2? Even if you're using the cutoff system model, your results might differ from the version 2.2. And this has a few reasons. The first one will probably be due to dataset updates. Of course, with the developing of the version 3, we didn't only change methodology and things like that. We also added a lot of new data, and this is modifying results, especially electricity, which was a big update made for version 3. This is impacting everywhere in the supply chain, so this can modify your results. We have done a correction in the allocation approach on some products respecting ISO hierarchy, but this also can change your results if you're working in this specific field where the allocation approach changed. We have updated the default transport distances, as I have explained when we were talking in the beginning about the markets. We have this systematic approach of adding the default transport distances in the market, and the default transport distances are now different than they were in version 2.2, a little bit. And now we consistently generate and use the consumption mix. It's something that is generated, as I said, for every product and always the same way. So just to close here and to start with the new data, the generation of the database happens as unallocated unit processes, and this allows the construction of several system models based on the same data, as well as allowing an easier update of supply chains. The construction of a system model is based on the definition of modeling choices that will be coded in a specific linking rules. 3 system models are available so far in version 3.1, and you have to choose the system model that best fits the goal and scope of your study, of course. And unless we have questions, I would move into the last section of the presentation.
We do not have any questions, so we can continue.
Cool. Okay, so then let's just end up this webinar talking about the new data and new features that were added for the version 3.01 and version 3.1, because as I was saying, we changed the methodology, we changed the structure, but we also added a lot of new data. And let's see a little bit what it was. So there were new data. You would see here I'm talking about version 3.01 and version 3.1 because some LCA tools have already make accessible version 3.1 for the users, but some are still in the version 3.01. So here you can see the differences. But if you're using version 3.1, of course, everything that was added in version 3.01 is also valid for you. It's just the other way around. So in version 3.01 already we make a big extension of country-specific electricity mixes. So now we're covering 90% of produced electricity in the world. We also, of course, updated the electricity mixes that were existing in the version 2. If you look at this map, you see in red, these were the data that were added new for ecoinvent version 3. In orange, this was data existing in version 2 and updated for version 3. And in the light yellow represents the 10% of electricity producers that we do not cover with specific data in ecoinvent. There were other new data added to version 3.01. Like, for example, the passenger transport by road. So we added combustion engine cars with different fuels like petrol, diesel, natural gas, and different sizes like small, medium, large, and also different European norms, 3, 4, and 5. And we added also an electric car. We added new data on fruit and veggies production, so we have around 30 new fruits and veggies in the database. So you can see in the picture, I think the picture contains most of them. Banana, kiwi, papaya, asparagus, ananas, cauliflower, etc. You name it, 30 new fruits and veggies. We also added new data on biofuel production, like for example, both in European and non-European locations. So for example, in Colombia we added sugarcane and oil palm production. In India and East Africa we added jatropha production, and in Europe we added, or we updated alfalfa grass mixture miscanthus, and willow. This is very interesting for biofuel production. We also updated building materials like cement and concrete, and we added new data on chemicals, around 80 new chemicals that you can now find in the database. To version 3.1, we added, in general, a higher degree of regionalization thanks to the collaboration with Canada. So the Quebec region of Canada developed their national database, and this database was developed with the methodology of the version 3 and within the context of the ecoinvent database. So a lot of new data on Canada and on Quebec have been added in the database in version 3.1, and some will come also in version 3.2. We also added an update of freight transport by road. So we updated Euro 345 and we generated new data on Euro 6. And in the case of the wood sector, we totally restructured the wood sector by restructuring the forestry part of it. So now you can find species-specific forestry activities, mainly sustainable management forest, but also we have boreal forest from Canada. And we restructured and added data at a very detailed level in the machinery, wood-based products, wood preservation, and the sawmill. We added also, we did a big effort on regionalization, and we added a very big level of detail in what concerns tap water production. So there are new infrastructure data, so new waterworks construction. There are new tap water production concerning the most important technologies on tap water production, and these located in different regions like global, the world, Quebec, and in Switzerland, and in general Europe. Very interesting, we got data from the International Aluminium Association, so we updated fully and increased the level of accuracy greatly of the aluminium supply chain. So this concerns primary, secondary production, electricity production, as we have been talking a little bit. We also updated and added data on incineration activities and also in heat production activities, mainly through wood-related products. We got new data on lineboard and cardboard in general, given by the FEFCO Association, by the Paper Producer Association, so also very nice data. And we got data on agro-food, for example, dairy, and like yogurt, butter, milk, cheese, and some soya derivatives products like soya beverage or tofu. And we also added a very interesting feature, which are the properties. So now every product in the ecoinvent version 3 database and every elementary flow and every resource or every emission will have consistently implemented 6 compulsory properties. 4 compulsory properties will concern mass, like the ones you can see in this slide. So you will see information on wet mass, information on dry mass, and on water or in wet mass. Of course, considering wet mass as the addition of dry mass plus water in wet mass. And you will have information on the water content, being the water contents, the water in wet mass divided by the dry mass. This is normally called U, especially by the wood, in the wood sector, especially. We also have, apart from those 4 mass-based properties, we have 2 more properties which are related to carbon content. So every product in the version 3 and every elementary flow bears information on how much biogenic carbon it has and how much carbon content fossil or carbon content non-fossil, sorry, it has. By fossil carbon, understanding the carbon coming from fossil fuels and calcium carbonates, and by non-fossil carbon, understanding carbon coming from plants and animals. let's see how do you as users see the properties in the ecoQuery. As I said, properties are available for all products, all elementary flows as well. So let's take this example of barley production in Germany. The product is barley grain, and here you can see the 6 compulsory properties: carbon content, fossil, non-fossil, dry mass, water content, water in wet mass, and wet mass. But you also have other properties. In this case is the energy content. This product has been also described by its energy content because it's used for animal feed, so then it's important to know this information. So depending on the product, other properties might have been added because at a certain moment it made sense for the modeling. So the fact of having now properties really increases greatly the level of detail of the information you can get from each product. So properties, as I was saying, are associated to products. That means that we can twist a little bit the concept of different activities can produce the same product, adding now the concept of properties. So the same product can have different properties depending on the activity producing it. And it can be because the activity is located in different geography, like for example, if we stick to barley production, we have our barley grain, which is produced in Germany, and which has water in wet mass of 0.14 kilograms. If we move to another geography, like for example Spain, the water in wet mass can change. Like in this case, it has changed from 0.14 to 0.15. But we can also think that the same product will have different properties depending on the activity producing it because we are changing the technology of the activity. And let's take this example of fatty alcohol sulfate, which is produced, in this case, based on coconut oil. And of course, we'll have a carbon content, which is non-fossil, of 0.52. If we move to another producer of the same product, so another producer of fatty alcohol sulfate, but which is producing it from petrochemical industry, of course the carbon content is the same, it's 0.52, but now it's fossil. So you can really twist the concept of product being produced by different activities and now adding the properties to get really interesting information. We have also updated the water flows. So if you have here it's an activity which will have inputs from Technosphere and which will produce a reference product. So the water flows that were in version 2 have been updated, like surface water and groundwater. They have been systematically updated throughout the database. And so those were, water flows, resource water flows coming from environment. Also the water flows from Technosphere and to Technosphere, like tap water, irrigation, and wastewater. They have been updated as well. But also new flows have been added. For example, water to water or water to air. And also the water content, as I was mentioning, the water content has been added in all products of the database. And we have, by doing this, ensured that we deliver to you a water balance database at the inventory level. That means that you can use this information to calculate your water footprint if you want, because we are providing you a water balance database. We are not providing results on water footprinting so far, but you can use the database to calculate that because it's water balanced. And just as a small reminder or just outlook, when you connect yourself to the ecoQuery, there are two very interesting tabs you should be aware of, which are those that are highlighted here, Files and Reports. On the Reports tab, you will find documents concerning sector-oriented information, for example, small reports, background information, etc. If you check the Files tab, Here you can see all the stored files to be downloaded, but also instructions on how to generate electricity mixes that are, for example, not available in the database right now, like US or ENSO, etc. So those two tabs are really interesting to check. And well, just to wrap up, there are new activities in version 3.01 and 3.1 concerning several sectors, as we have seen. You can check this link that will lead you to the activity overview file. This is an Excel file that is listing all activities in each of the versions of the database, so all activities, all products, and also the activities will be classified by ISIC code. That's how we classify the activities now. ISIC code being a UN classification, so you can filter by activity, by sector generally, and you can find wherever new activity is there. New features we have developed for version 3 include new properties, mass related and carbon content related, and the water balance is ensured at the inventory level. So don't know if we have remaining questions. We have 5 minutes.
Yes, we have one which is connected to the properties and their use in the impact assessment methods. I will read the whole question. With the distinction between fossil and non-fossil carbon content, is it then possible to produce GHG, global warming potential impacts, which discern between fossil and non-fossil contribution to the global warming potential?
Okay. Thank you. So important thing for you to remember is that the properties we are providing now, there's no impact assessment method that is able to use the property in order to assess the impact assessment. There are no characterization factors that are taking into account properties in whatsoever way. This is not yet happening. If ever the impact assessment developed to be able to take into account the property, then of course I can imagine that yes, they would be able to take into account the fossil and non-fossil carbon to discern different characterization factors, so different results. But so far this is not happening. The properties are there only for your information. If you're doing accounting in an independent way, if you're accounting for carbon in an independent way of an impact assessment method, you can use the properties, or if you're doing calculations to construct your supply chain or to construct a new activity, etc. So I think that then...
That's all, no more questions.
Okay, then I thank you very much for being there, for being so active. Many questions, that's always very nice. And I hope you enjoyed the webinar, and I guess Teresa has other things to say at the administrative level. Thank you very much.
Thank you, Emilia, for the webinar in general. I would just like to add a few technical things. So, as I said at the beginning, I will repeat it because not everybody was signed in when I was saying that. This webinar was being recorded. There will be a video available on our website. I just sent you all the direct link to the website where you can find it, but basically it's the ecoinvent website. There is news and events and webinars that you can find the link to the video, but also you can find there the slides, so the presentation itself in the PDF format, it will be available there. Otherwise, if you have any more questions which you didn't have time to ask during this webinar, you are of course welcome to contact us anytime on the generic ecoinvent support email. One more thing is that in a few days you will receive from us a short questionnaire where we are asking you a question of how did you like the webinar, if there were things which were difficult for you to understand. So basically we are asking you how we could improve into the future of the webinar. We are also asking you questions about if there are other topics which you would like us to make a webinar on. So for example, if you would like to see more detailed information about the properties which are now available, prices, for example, or more detailed information about the markets, or if you would like to have a specific webinar for every different system model in order to understand it a little bit better. So I would really like to encourage you to have a look. It will not take you more than 5 to 7 minutes to fill it in, and we will be really grateful for the feedback. Okay, so that's all. Thank you very much to all of you for attending, and have a nice day.